Hey there, Joel here, and welcome to the second part of this video. Is matter around us pure? I hope you watched the first video. If you haven't, then please go ahead and watch that and come back to this video for better understanding. And if it's the first time that you're here, then please don't forget to subscribe to this channel. I've noticed that most of my students who watch the videos don't subscribe, so please hit that subscribe button. Okay, now in the previous video I had spoken about something called as, you are mixing sugar in water and I said you get a solution. So what is this sugar, what is this water, is what we are going to understand today. So I have a glass of water and then I have some sugar crystals. I mix them, and then, or it was not sugar, it was salt. It can be anything. So the minor component in that solution is a solute. So I took water and I put 1 spoon of salt, right? What is less or what is minor? It is a salt, right, that is present. So that salt which you mix is a solute. Same way, when am I mixing that salt in? I'm mixing salt in water. So when I do that, that water is nothing but a solvent. Okay, clear? Next, when you mix that salt and solvent, or the solute and solvent together, you get something else, right? That is a solution. So that salt water that you get is a solution. Simple to understand, don't have to by heart anything. Please remember that the less component that you are adding is a solute, the little more quantity is a solvent. Together it's a solution. Okay, next, here I have 3 lime juice, you can say lime soda or lime water, and I'm considering, entire lime water as a solvent, whereas lime itself will become a solute, water will become a solvent. You mix them together, lime water will become a solution. But just to make things a little bit easy for you to understand, we'll say that lime water is one of the solvent, and in that I'm going to add sugar. So I put half a teaspoon of sugar in that lime water. So what will happen? Has little amount of solute in the solvent. So I am adding a very little, a tiny, few grains, you can say granules of sugar. In the second one, I am putting 1 tablespoon of sugar, and in the third one, I am putting 3 tablespoons of sugar. So definitely the third one will be the sweetest, okay, and the second one will be slightly less sweet, and the third one will be not at all sweet, right? That's when you are able to understand what do we mean by a dilute solution, concentrated solution, and saturated solution. So in a dilute solution, it has a little amount of solute in the solvent. In concentrated, you have the required amount of solute dissolved in that solvent, and in saturated, you have more of solute and cannot be added more than that. So I'm adding sugar to a point that if I put little bit more sugar inside that solvent, it is not going to get mixed anymore. Okay, that level, that highest peak that you can say where you're reaching, where you can't add more sugar, is called as a saturated solution. So dilute, concentrated, and saturated. Dilute is when you have very little amount of sugar or any solute in it. In concentrated, you have the required amount, and in saturated, you have to the topmost level that if I add more solute, it's not going to get mixed at all. So that is called as concentrated. Next, let us study about physical methods of separation. One of the method I had already told you in the first video, and that was hand picking. So let us study a little bit more different kinds of physical methods. Okay, so here sieving is one of the example of physical method. The picture itself will help you understand what do we mean by this. Probably you have done it at home. Okay, so sieve, I take a kind of a net and put the particles in there and then sieve it. So whatever tiny particles can pass through that net will fall down, whatever can't will remain inside. So sieving is one of the method. Second is hand picking. Maybe you brought rice from the market and then mama tells you remove all those stones which are there in the rice. I hand pick them, right? So hand picking. Next is filtration. So what I do is, if I have mud and water mixed together, in that mud and water, mud will be what? Mud water is a solution. So you can write down in the comment section, what do we mean by that? Mud, what is water in that case? Okay, so here we are taking the mud water and using a filter paper we are trying to separate it. So filtration. Next method is evaporation. So if I have salt and water mixed together and I want to separate water and salt, all I have to do is put in a container and boil it, right? So when I boil, water will start evaporating and I collect that water in another container. Salt will remain there. Evaporation. Next is centrifugation. Centrifuge is nothing but, you can imagine this as a merry-go-round. And then you're sitting there and then someone comes and rotates that merry-go-round very fast. And then you are about to fall off, right, from that merry-go-round that is there. Something like that. Or you can think of a washing machine. When you take your clothes and dip them in water and put it in the washing machine for spinning, what happens? The spinner, the washing machine will rotate your entire clothes in such a speed that the water and the clothes will be separated, right? Centrifugation is the idea. And next is decantation, a simple method, especially used when the particles do not dissolve in the solvent. So just put them there and use a stick, kind of a glass rod or something, and then pour it. So whatever is, maybe when you are trying to separate tea powder from tea, right? Whatever can be mixed will get mixed, and finally those tea leaves will remain inside, right? So you can use this kind of a method, okay, because those particles will settle down, tea leaves, and then you can separate it. Next is sublimation. We have already studied about sublimation in the first chapter. If you still don't have any idea, then please go ahead and watch that video. Okay, next is chromatography, where it is used to separate dye from its colors. So your ink that you write with, the blue color ink, is a dye. It has many colors in it. So if you take it and keep it in a tissue paper or a filter paper, then all those colors will get separated. It moves up in that entire process, right? So that's called chromatography. So you have a solvent, that is my ink water, I can say, and I'm dipping a piece of paper. So what happens is it will, or let me give you, maybe you must have not done this experiment but experienced it. Maybe one day you are writing on your book and then you just left your book there only and then went to do something else. And then there was some water droplets that fell on the book, and that ink that was blue, now suddenly you can see some pink kind of outline to it. How that has happened? Because of chromatography. Next is distillation. I'm sure you know what is distillation. When you have certain chemicals, especially your alcohol separation, then fuel that is there, all the petroleum products are either done by distillation or fractional distillation. The difference, I'll tell you, the gap of at least 50 degrees is required when you're talking about distillation. What do we mean by this? I have a solution which has two different substances mixed in it, and I want to separate them by distillation. So when I'm doing that, the first substance and the second substance, the temperature that it requires to get distilled should be at least 50 degrees. Then I can use distillation. If it is less than 50 degrees or less than 25 or so, then you use fractional distillation. So that's it about the different kinds of physical methods of separation. I'm hoping that you have understood all this. I've gone through it the most simplest way possible. Please read your textbook to understand each and every part more carefully. Now, elements can be further classified as metals, non-metals and metalloids. Okay, now what are elements? Elements are basic form of matter which cannot be broken down into simpler substance by chemical reaction. So gold becomes an element. I can't further do any chemical reaction to separate it any more further. Okay, that is what it means. Now, mixtures and compounds. So we studied about elements. We are looking at mixtures and compounds. So what are they? It is composed of two or more elements or compounds mixed together. Already explained to you, right, what is a mixture at the start. There we said it's two different substances. Here we are specifying what is the substance. Either it is an element or it is a compound. In a compound itself, it is composed of two or more elements chemically combined together. It is not just present with each other, but combining and bonding with each other. That is called as a compound. So, can I say that sugar water becomes a compound? No, because they are not chemically bonding with each other. I can use physical methods to separate them, right? So when we are talking about a compound, you can't use any physical method to separate them. Next, the composition of the components is in a ratio. So I can have some ratio to make that mixture. The composition of the components is in a fixed ratio. So when we are talking about mixture, I gave you example of chuda in the previous video. Even if I put few cashew nuts extra, will that mixture be something else? No. When we are talking about a compound, they are in a fixed ratio. The recipe has to be followed right. If it is not, then it becomes a different compound. Like for example, O2, that means two oxygen atoms together will give you oxygen molecule. But if I take O3, that means 3 oxygen together, then it gives you ozone. So here the combination, how they are combining is different, okay, in a compound. The ratio is very important. Sorry. It shows the properties of the component. So when I remove that cashew nut and eat it, it gives me that property of the cashew nut. I can feel the taste of a cashew nut. But when we are talking about a compound, the properties completely change. For example, hydrogen burns with a pop sound. You must have done this experiment in your lower classes. Okay. Oxygen helps in combustion. But when you combine hydrogen and oxygen together to get water, water is a compound. But the property of water is completely different. Water doesn't burn. Water extinguishes fire. But both hydrogen and oxygen were in some way helping for combustion, right? So the properties of the compound completely change. Then the components can be separated by physical methods. In a mixture, we have already learned which are the physical methods, so I can use those to separate a mixture. But here in a compound, physical methods cannot be used. We need to use chemical methods to separate compounds. I hope you are able to understand each and every point of mixtures and compounds. Please go through it, write it down, understand, don't by heart them. Okay, I'm against by hearting. So understand the methods properly. Think of the mixture and a compound with an example. So the moment you have an example in your mind, you will be able to write the points very easily. So in this case, mixtures, I'm talking about the chuda, right? So thinking of chuda, I can write the points. Thinking of oxygen or water, I can write the properties of a compound. Alright, that's it for this today's class. I hope you have understood all whatever was explained. If you did, then please don't forget to hit that like button, subscribe to the channel, share this video with your friends so that they also enjoy learning science in a better way. Till then, take care and bye-bye. God bless you.